Welcome to Chapter 12. We're going to start out here with 12.1, talking about tangent lines. Our objective is to use properties of a tangent line to a circle. Our first definition, a tangent to a circle is a line in the plane of the circle that intersects the circle at exactly one point. The point where the circle and the tangent intersect is the point of tangency. So if we've got our circle C here, we name it circle C because C is the point in the middle. And we've got our line L right here. It intersects at point D. Okay, it intersects at a single point at D, so L is going to be tangent to our circle, and D is our point of tangency. Our first theorem in chapter 12 is 12.1. If a line is tangent to a circle, then the line is perpendicular to the radius at that point of tangency. So for example, if we've got the line AB and it's tangent to circle O at point P, so it hits it at that point right there, then we can say that the line AB is perpendicular to OP, which means it intersects at a 90-degree angle. Okay, so our first example here, ML and MN are tangent to line O. So this line and this one are tangent. So they intersect at a single point. It also means that they are perpendicular. So because they are perpendicular, they make 90-degree angles. So I know 3 of the 4 angles that I need. So I've got a 90, I've got a 90, and I've got a 117, and I don't know what the last one is. Now, 4-sided shape, the angles should always add up to 360. So if I add all of these up with x, 90 plus 90 is 180, 180 plus 117 should get you 297. If you subtract that over, x should be a 63-degree angle. For our next example, ED is tangent to circle O, so right away, ED, I should be putting a 90-degree angle there. They want to know what the value of x is. Well, now I've got a triangle, and I know what 2 angles are. I've got 90, and I've got 38. I just don't know what the third one is. Triangles should add up to 180. 90 plus 38 is 128. So when I subtract that across for x, so I subtract 128 from 180, I should get 52. X is a 52-degree angle. Our next example, we've got the CN Tower in Toronto, Canada. Has an observation deck 0.45 kilometers above the ground. So that is this point T up here. But about how far from the observation deck to the horizon. So if we do a straight line to the horizon here, we are going to have a tangent line. It's going to intersect at point E, which is going to give us a 90-degree angle. They want to know this distance here. They tell us that the Earth's radius is about 6,400 kilometers. So this distance is 6,400, and so is this one. So when I bring my triangle out here, I got x here, I've got 6,400 here, and I've got 6,400.45 here. To solve this, I've got 2 sides of a right triangle, and I'm looking for the third one. That means we're going to use the Pythagorean theorem. Okay, a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. So I've got one leg squared plus the other leg squared is equal to the hypotenuse squared. So I've got x squared plus 6,400 squared equals 6,400.45 squared. Well, x squared doesn't change. 6,400 is 40,960,000. And 640.45 squared is 40,965,760.2. And when I subtract the 40,960,000 over, I get that x squared is equal to 5760.2. And if I take the square root of that, I get my answer for x as about 76 kilometers away. Our second example, what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above the Earth? And the Earth's radius is now 4,000 miles. So if we've got our circle, and let's just draw in our radius here, we've got 4,000 miles, and we're going to be another 2 miles up here, and we want to see that way. Okay, so that's 2 miles, and then the 40,000 miles, so this side is 4,002 miles. This side is just 4,000 miles, and we're looking for x. Again, 90-degree angle. We're going to use the a squared plus b squared equals c squared again. X squared plus 4,000 squared equals 4,002 squared. Typing these in, 4,000 squared is 16 followed by 6 zeros. 4,002 squared is 160160004. When I subtract the 16 with the 6 zeros over, I've got x squared is equal to 16004. I take the square root of both sides, and I get that it is about 126.5 miles away. Our next theorem, if a line in a plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent. So if we know that the line is perpendicular, then we know it's tangent. It's kind of the corollary to the one before. It's the opposite. Okay, we went from one to the other, now we're going from the other back to the first one. Okay, so our example here, what is the radius of circle C? So we've got our triangle here, we've got a length of 12, an 8, and then our radius is x. So we're going to be solving for x. We're still going to be using our Pythagorean theorem here, because I know all three sides. I've got the length of the first side, or first leg, plus the length of the second leg squared, and I'm going to set it equal to the length of the hypotenuse squared. Well, x squared is x squared, 12 squared is 144. When I square x plus 8, remember, x plus 8 squared is x plus 8 times x plus 8. So I'd have to FOIL it. I've got x squared plus 8x, so I've got plus 16x plus 64. Okay. Solving for x, I'm going to subtract the x squareds over. So when I do that, minus x squared, they actually cancel each other out. And I'm left with 144 is equal to 16x plus 64. Subtract the 64 over, and I get that 80 is equal to 16x. Divide both sides by 16, and I get that x is 5. My radius of my circle is going to be 5. The next part is going to be to identify whether a line is tangent to a circle or not. And you'll notice that for each one of these, we are going to have a triangle. So now the question is this a right angle? Now the way to prove that, again, is to use my Pythagorean theorem. If I use the Pythagorean theorem and it works, that means that this triangle has to be a right triangle, which would mean this has to be a right angle. So when I go to try it out, the two legs squared and added together, 7 squared plus 24 squared, and it should be equal to my hypotenuse squared of 25. Well, 7 squared is 49, 24 squared is 576, 25 squared is 625. If I add 576 and 49 together, I get 625. 625 is equal to 625. Yes. So therefore, it is tangent. Since they are equal, that is a 90-degree angle, and if it's a 90-degree angle, it's a tangent. So that's how we know that works. Same thing down here. I'm looking for whether this is a 90-degree angle or not. So I test it out. A squared plus b squared equals c squared. Does this work? Well, 2.5 squared gives me 6.25. 6 squared is 36 squared. 7 squared is 49. If I add these two together, I get 42.25. So according to this, 42.25 is equal to 49. That does not work. So we say no, that is not tangent because it doesn't form a 90-degree angle. The last theorem in this first section, if two tangent segments to a circle share a common endpoint outside of the circle, then the two segments are congruent. So if you look here, I've got segment AB and segment BC. They both touch the circle, they both meet at point B, so therefore this distance is congruent to this one. Okay, so in another definition, we've got a circle is inscribed in a polygon if the sides of the polygon are tangent to the circle. So each side intersects it at one single spot. So we're going to be using that. We're going to say a circle is inscribed into the polygon, and so you know that that'll mean that the sides are tangent to the circle. Problem number 5, circles inscribed in polygons. They want to know the perimeter of ABC. Okay, this triangle out here. So to start out with, this distance is 10. This distance shares an endpoint and also hits the circle, so this distance is also 10. We've got a distance of 8 and another distance of 8 since they share an endpoint. We've got a distance of 15, so we'll have another distance of 15 here. So our perimeter is, I'm going to add all those up, 10 plus 10, plus 15 plus 15, plus 8 plus 8. Okay, so we've got 20 plus 30 plus 16. 20 plus 30 is 50, plus 16. The distance should be 66 centimeters. Same thing here. If this distance is 8, then this distance is 8. If this is 6, so is this. If this is 9, so is this. If this is 16, so is this. So I'll need to add them up. 8 plus 8 plus 16 plus 16 plus 6 plus 6 plus 9 plus 9. And when I do that, I get 78 centimeters.